Hi guys, welcome to the channel. Today we're going to be reviewing how to do a Bohr Rutherford diagram. First of all, we're going to quickly look at the periodic table. So this is the periodic table of elements, and you would notice that there are different symbols and names and different numbers on there. So if you look at, I have, say, carbon, C, it has a number 6 at the top, which is the atomic number, and it has the number 12 at the bottom, which is the atomic mass. So notice numbers at the top. If you quickly look at, say, another version of the periodic table, say this particular one, if you see the C, I have the number 6 on the left and number 12 on the right-hand side. You have to be careful that when you're doing your Bohr Rutherford diagram that we're coming up with a standard way of how to write the numbers and what they represent. So I'm going to quickly go over and review this thing called the standard atomic notation. Okay, so this is what we use in a lot of chemistry situation, and you notice that it is written with X represent whatever the symbol that we're going to be talking about, A and Z. All right, so let's see what it is. So just now we were looking at, say, carbon. In a particular version, we have a number 6 at the top, and we have a number 12.0107. Okay, the 6 represent the atomic number. And the atomic number, we actually use the symbol Z to represent that. So if I were to write this carbon in standard atomic notation following this format, I would write the symbol C. I would put the number 6, which is the atomic number, at the bottom of the number. And then see how this other one now, the 12.0107, this is called the atomic mass. They used a symbol of A to represent it. So atomic mass, so meaning for carbon, first of all, you have to round it to the nearest number when we're drawing the Bohr Rutherford diagram. So this one, I'm going to round it to a whole number of 12, and I'm going to stick it at the top here. So from now on, you're going to be writing every single element in 12 at the top, 6 at the bottom, representing the atomic mass and the atomic number. So now that we've written, say, carbon, in the standard atomic notation, we're now going to start interpreting what the number will be meaning, because ultimately there'll be 3 pieces of information that you will need to get from this. I call it the Penn number. Okay, so it's an acronym for 3 things that you will need to draw your Bohr Rutherford diagram. P stands for number of protons, E stands for number of electrons, and N stands for number of neutrons. And within these guys, electron goes on shelves around the nucleus, while the proton and the neutrons are going to be inside the nucleus. And if we actually take a look at these numbers, this is how you would calculate them. So atomic number, it's always going to be the same number as proton and the same number of electrons. That is considered to be an atom. Later on, we're going to be talking about ions, which is a totally different thing. But at this point, drawing a neutral Bohr Rutherford diagram, these 2 numbers are going to be the same. And the last one is now, how do I calculate neutrons? So basically, to calculate the neutrons, what we have to do is we actually need to do a calculation. I mean, there's only 2 numbers here, and the calculation is subtracting, and neutron is the one that we're going to be subtracting. We're going to take the number, we're going to take the atomic mass, and we're going to subtract it with the atomic number. So in this particular case for carbon, what I would write down is every time when I'm drawing Bohr Rutherford diagram, I would first of all write down PEN. Reading from here, I know P and E both always equals to the atomic number, which is going to be 6 for carbon. And then neutron is the only one that involves calculations, and I have to subtract these 2 numbers. So 12 minus 6, I have 6 neutrons. Now going about how to draw these, we draw a solid line to represent the nucleus, and we already said inside the nucleus we got protons and neutrons. So protons that I've already worked out, I have 6 protons inside, so I'm going to write 6p with a little plus sign to represent that it has a positively charged. And then neutrons, we also worked out to be 6, so I'm going to write down 6 neutrons, and so 6 and with a little symbol of 0 to represent the neutral charge. Now the rules for the electrons is a little bit more tricky. They go on shelves, and there are limits on how many electrons can go on each shelf. So if this is my nucleus, we usually draw dotted line around to represent the electron shell. And in general, we would not go past the fourth one because we're only going to be covering from atomic number 1 to 20. And the limit on how many electrons can go on the shelf goes like this. The first shelf, I can fit 2. The second one, I can fit 8, 8, and 8, and so forth. Okay, so now please watch carefully how the dots are being drawn now. So I'm going to first of all put my ring. There are 6 in total that I have to put. And so carbon actually would have 2 rings because I have 2 that fits in the 2. And then I have 4 extra ones to go onto the second shelf to make 6. So I only need 2 electrons shelves. Make sure that you don't start drawing your electron on the nucleus because the electrons don't go on nucleus. They go on the shelves around the nucleus. Okay, so this is how you draw it. So I first of all have 2. I have 6 in total that I have to draw. These are the dots that goes on the shelf. I have 2 that need to go on the first ring, and we put them beside each other. So 1 and 2. So make a little side note here. You can do this in your head, but I have 6. I already drawn 2. I still have 4 more to go. And can I fit 4 inside the second ring? Definitely. I have 8 that I can fit in total, and I have 4. And the way that you would draw them is they actually do go in pairs, but you start out with single ones going clockwise around the ring. So I have 1, 2, 3, 4. So notice that now I actually have 6 in total, and it goes into the 4. We're going to do one more example. We're going to be drawing a Bohr Rutherford diagram for fluorine. So I'm going to just take one of my periodic table and I'm going to take a look at fluorine. Fluorine has 9, and then the other number, atomic mass, is 18.99. So I'm going to round it to 19. So the first thing that I'm going to do is I'm going to write the fluorine in standard atomic notation. So I have 9 at the bottom and 19 at the top. And before I draw it, I'm going to write out the pen number. Your teachers might not let you know to actually write the pen number and then draw your picture. I tend to like to do that so that I know I have all the information that I need and they're correct. And we already said the atomic number here is always going to be the same as P and always going to be the same as the E. So that means I can write 9 and 9 over there for protons and electrons. So now my N number, number of neutrons, that's the one that I would have to subtract the 2. So I have to go 19 minus 9. So the number of neutron in this case will be 10 in total. Draw my nucleus. Inside my nucleus, I have the P and the N. So I have 9 protons and 10 neutrons. And I need to start drawing the rings. I have 9 in total that I need to draw. I know that it goes onto the 2 rings. Okay, 9 in total, so please watch. 1, 2 on the first ring. They go in pairs at the top. 3, 4, 5, 6, 7, 8, 9. Okay, if you need to keep going, if there's more, like the atomic number is bigger, you would fill out the next one and then draw the next ring that will fit 8 and then draw the next ring if you want. So hopefully this is a helpful tutorial for you, and just practice and just double check. Common mistake is if the number of neutron is not the same as the electron. I find that people often draw the dot as a 10. Don't forget, the electrons are the ones that are the dots, okay? So don't start drawing 10 dots just because you have 10. The 10 is inside the nucleus. That's probably one of the most common mistakes that I've noticed. But other than that, this should be fairly easy. Thank you so much for watching. Now it's your turn to do some practice. Hope you get really good at it. Bye-bye.